All right, we're gonna catch a refrigerant recovery on thermal camera, and as you can see, the tank with the little blue X on it, or I have the right there with that blue X going around, that's the temperature supposedly of the tank, and that is the minimum. It says 59 degrees. Then you could see the red X moving around on the motor, looking through the hot oil on the face of my recovery unit right there. You see right there? And that's the maximum temperature at 85 degrees. Now what we're going to look at, the bottom of the condenser, and as you can see for the condenser, where the green square in the center says the center, and that says 61, 64, something like that degrees. But I also have the temperature clamp on the liquid line leaving the condenser. Then I have it on the liquid line coming out of the condenser and going into the receiver dryer right there. And the bottom few rows right here, 1, 2, 3, 4, 5, 6, 7. These 7 rows are supposedly filled with liquid refrigerant. And if we look at their temperature, it says 66 degrees, 65.3 degrees. So that's the temperature of the lines. And if we look at the temperature of the hood right here, and we come up here and look at the temperatures, 67, 65, 66. And you go, why is there so many different temperatures? Well, do you see that reflection? See how that has some shine to it? So when you're up here, you get heat from heat sources behind you, hitting the shine, reflecting back into the lens of your thermal imager, including your body. If that was a shiny aluminum and I move my body around, you would see these temperatures move around because my infrared light, and infrared is a light, is hitting the surface and bouncing back and giving false numbers. So let's get the show on the road and see what happens on this situation. There we go. Let's get down here and watch it turn black. You see it turning black? See it getting darker and darker? You see that minimum temperature going down? That's the liquid refrigerant flashing because I'm recovering out of the section line. Look at the receiver from up here. You can see it mostly down there. You can see my handle of my gauge, but then you can see the minimal part right there, 47 degrees. Now let's look up here. 47 degrees, it just hit 46.9 going down. 59 degrees. Where's 59 degrees? On the low side. That is this one right here. So if we come over here, you see that dark line? That's what we're looking at, and that's what it sees. 30 degrees, 29 degrees, 27 degrees, 26 degrees, because there's liquid in there, and it's boiling. You have boiling liquid refrigerant right where my temperature clamp is. This would be a more true. See, this said 20 some degrees, but that's coming off aluminum, shiny kind of. This is direct contact, 27 degrees. There it goes, it's now 27, 28. Now, when you see the temperature start going up, you see the temperature going up, that means there's no more liquid at that point. And now the aluminum is starting to absorb the ambient temperature and heat that line back up because the liquid has just vaporized. And you'll see the temperature's going up now. And we had pure refrigerant. It's 134, only a little bit of air in it. And we're pulling out from the vapor line only. And we just got down to -3 vacuum, but now it's going back up. So now what you're watching is, this is the refrigerant boiling out of the oil, just like CO2 in Coca-Cola. You know, when you snap the cap onto Coca-Cola, the big 2-liter bottle, you hear the big whoosh of CO2 coming out. But then when you put the cap back on, it repressurizes. And that's exactly what's happening here. CO2 and refrigerant are basically the exact same thing, and think of as the oil or the water of being the same thing. You look at, see that cold area over there? That's where the liquid puddles and is mostly the mass of the metal, because you have the headers that got really cold and they have a high mass. And then you see in the middle, the ambient air is warming up the middle really fast because they have fins. But as you get to the edges, you're getting to high mass that got cooled down, so it takes longer. This is all stuff you were taught in middle school and high school in science class. It's nothing new. It's just that most of everybody didn't pay attention and thought it wasn't going to be important sometime in their future. And now here you are today watching this video going, why can't I do AC good? Why are some things mysteries? Because didn't pay attention in school. That science teacher knew what you would need if you got into an automotive business, especially today with electricity. Well, let me continue on here. And let's take a look over here. What's going on over here? Oh wow, look at that tank. Remember that tank was cold? In comparison, you can see the motor over there, but look at that tank. That tank is no longer the coldest thing. Let's get up here towards where it goes in, right there. See, the knobs are cold, they're plastic and they're suspended out in air, but right at the entrance point, you got maximum 81 degrees right at the little, right as it enters at the hot spot. All right guys, hope somebody got something out of this. I'll see you later. And yeah. All right, see ya.